While working on Project Pegasus, I discovered a powerful way to author global color maps using the native Heightfields. First, let's put down our own Heightfield. As always, we'll apply a little bit of noise to it. And let's get started straight away looking at how we can author our own global color maps and sort of terrain textures using the native Heightfield tools in Houdini with just a little bit of X. So by default, if you mask your Heightfield inside of Houdini using the mask by feature, you end up with a mask that you can use to drive the placement of different layers. You can use the Heightfield visualize, and you can even set up some custom kind of coloration, which takes advantage of these masks here, like so. So you can, of course, do some rudimentary coloring just using these tools out of the box. However, you're limited to a set number of layers here. And additionally, there isn't an obvious way to export the resulting color map to disk and to use an external program. So how do we get around this? Well, we're going to remove the material. So we end up with a blank Heightfield again. And this time we're going to set the tinting to use custom tinting. And where it says color layer here, instead of leaving the default option of mask, we're going to type RGB like so. And then we're going to set this up so that it's just a black to white ramp. If we can get that to work. Let's try once more. They're very interesting. Seem to have a slight problem here. It's going to try another way. There we go. So now we have a black to white ramp. RGB, excellent. So basically, we're telling the Heightfield visualize that we're going to supply it with 3 individual Heightfields, and each Heightfield is going to be named accordingly RG and B, and it's going to drive that channel of this kind of black to white gradient. So we're essentially setting up the visualize to render color. 3 channels of color, I should say. So how do we then supply the Heightfield visualize with some color information? Well, it's quite simple. We can start by putting down a volume wrangle, or even simpler than that, we can do Heightfield mask noise. And just to begin with, we're going to set up a noise layer called R, a noise layer called G, and a noise layer called B, like so. R, G, and B. I'm going to set them all to be replace. And okay, we're not seeing anything. And that's because this RGB and layer don't actually exist. Why is that? We've told the noise that it should create the noise inside those layers. Well, one peculiarity here is we just need to make sure that those already exist ahead of time. Those 3 named layers. So we can use Heightfield copy layer like so. I'm going to copy the mask 3 times, once into R, once into G, once into B. I'm going to go ahead and turn off copy source data like so. Okay, so we're seeing something. We're seeing sort of this black and white gradient. And now I'm just going to bring down the scale there, make it a bit higher frequency. And we're still seeing only black and white. Why is that? Well, it's because we're using the exact same noise in all 3 channels. So I just need to apply a slight offset like so. And now you can see that we're getting some R, G, and B noise on the terrain. Not seeing an awful lot of G there, so I might actually just add another offset in that axis. And there we go. Okay, we've got colored noise now applied to our terrain. So we can see that in fact, that is visualizing correctly. All right. So now that we've got those kind of color layers, we can go ahead, we can do a Heightfield Heightfield output. Like so. We can leave it on RGB 16-bit, because we're only interested in 16-bit color at the moment. And then we type in R, G, and B like so. We can name this. I should go ahead and save my project first of all. Ooh, there. So just finding the sensible location to save this. Go, color map workflow. Heightfields color. All right. And then I'm going to say $hip. So the current directory, Heightfields, and RGB noise.png. There we go. So I go ahead and save that to disk. Now if I click floating file chooser, get that path, and go check that location out, and we can see we've exported our global color map, or a color map. Okay, so this was the basics. I'm going to go ahead and bundle up this noise, and I'm going to go collapse the subnet. I'm going to call this RGB noise. Okay, I'm also going to cut the visualize out and paste it up above here. We can look and see the RGB noise is still displaying correctly. So this visualize gets passed down through the node chain. So I'm going to set this up with a null ahead of that RGB noise, and I'm going to call that, let's say, terrain for texturing. Okay, so that was a basic example. What about something a little bit more advanced or useful? This time, I'm going to use file inputs. So I'm going to set up not file inputs, my bad. Heightfield file, or Heightfield file, not tile. There we go. I'm going to say we want to use the default pick. That's fine for now. We want to get the first channel of it, red. There we go. I'm going to call that layer R when it comes out. I'm going to set it to replace it. All right. Then we're going to go ahead and do the same, but we're going to make sure we use the green channel of the incoming image. We name that layer G. And next up, we're going to do the same thing again. Blue, I'm going to call it B. Okay, so now we have a look, and we can see that as each of those layers gets imported, it gets read correctly and applied to the terrain as you would expect it to do so. All right, so we've got basic noise, we've got a nice texture, and lastly, what if we wanted to just kind of go ahead and apply a tint to whatever is already there? Well, for this one, we're just going to use a quick volume wrangle, like so. And we can say at R equals, at G equals, and at B equals. Then we're going to set up some floats, one for each channel. In fact, we're just going to use a vector here. So we're going to say vector, vector color equals CHV color. So some color that we're going to set as a parameter. Okay, so you can see that's created those channels there when I clicked the create spare parameter button. I'm just going to go ahead and edit the parameter interface quickly. I'm going to make sure that instead of just using a float vector free, it's actually expecting a color input. You can see now we get a little color picker, and I can go ahead and pick some color like that. By the way, I'm pressing Alt / to expand and pop down these windows. So now we have vector color equals color, and I can type in color.r. No, I can't. Color index 0, color index 1, you guessed it, color index 2. And now we can see we have the ability to go ahead and tint this terrain whatever color we want. Okay, so we've got tinting. Going to collapse this as well. We've got texture-based color. And of course, we've got our first one, which was the RGB noise, like so. And with these kind of basic ingredients, we have pretty much everything we need to start authoring our global color maps. There's some extra steps we need to take though, because we don't just want to be able to drive the terrain by just a single texture nor a single color. We want to be able to do it sort of by blending according to the masks that we have applied to the terrain. So what I'm going to do is I'm going to drag this out to the side there because it's actually not needed in this main thread. And I'm going to call this slopes. And actually, why not? Let's go ahead and grab an object merge and get the terrain for texturing. So we can treat this as its own sort of independent thread of operations off to the side. No, actually, because we've got the visualize here set up to visualize RGB already, I'm going to create an additional null previous to that, just after the noise. I'm going to call this terrain for splats. I'm going to wire that up there. And what we're going to basically try to accomplish now is in this kind of region off to the right, we're going to create a variety of different masks and splats. And we're going to make those be driven by this terrain for splats node coming from the main thread. And then we're going to take the outputs of all of these operations. I'm going to use these to drive a variety of different colors and effects, things that we might want to blend together there. So we've already got our slopes. Let's also go ahead and do another mask by feature and grab ambient occlusion. And I'm going to leave the default ambient occlusion because I think smooth gradients suit coloring quite well. And I'm going to apply that same principle to this slopes as well. So we're just going to do linear like so. I'm going to adjust these two parameters so that we get this kind of nice soft fall off. I may actually try make it sharp. That's what I think I like for sort of some color operations. And then finally, maybe a flow field as well. So we'll grab that terrain for splats. I'm going to set this to smooth. I'm going to decrease the number of iterations there. Nice. Okay, so we have slopes, we have AO, and we have flow. And now we want to use these to drive how the colors are going to get applied to our terrain. So we're going to treat this as our initial example. So we're going to do an object merge, plug in the terrain for texturing, and then we're going to wire all of these in. Sort of call this basic examples. I'm going to grab that object merge once more. This is going to be our kind of real examples now of how we might use this to actually author our global color maps. So first of all, let's use the slopes to drive a very simple kind of blend of color. In fact, actually even more basic than that. Let's just have a simple height-based blend as the basic background. Mask by height, compute range, linear. There we go. And this is going to allow us to sort of have a gradient of color going from the valleys up to the peaks there. I'm going to make another object merge. I'm going to grab the height there. So we have our terrain for texturing and the height, which is going to drive our initial colorization. So I'm going to just do a bit of tinting to begin with. I'm going to take in our first input, that is the terrain that we want to apply the color to. And we're going to wire in the second input there, which contains the mask that we want to drive the color by. And let's have a think for a second. Do we actually want to do this in Vex? No, let's keep things as simple as possible. Let's actually do a HF layer like so. And this allows us to copy a layer from one source onto another source terrain. We wire it in like so. And the layer that we want to replace is going to be the mask. Okay. And then inside of this tinting, we're going to use the mask to blend effectively between two colors. So I'm going to set up a new vector source, color, vector, new color. There we go. And then vector color is going to be our final color. And the vector source color is going to be equal to, actually, we have to declare it first. So what it's then going to be equal to is source color, 0, 1, 2, because we're going to have to set each channel from each incoming color height field. So that's going to equal R, it's going to equal G, That's going to equal B. And I've done a typo there. Just something there. Okay, so we have our source color. We have our new color, which means vector color is going to be lerping between source color and new color via at mask. At mask being the layer that we replaced. Excellent. And we can now see that that blue is getting applied more strongly at the tops than at the bottom of the terrain. You can see the blue there. So what I've actually done here is I've set up a tinting that only has one color, so it's sort of allowing you to sort of control the strength of the tint that's being applied over the previous color. So we're going to go ahead and grab that tinting, that basic tinting again, once more. In fact, no. We're just going to copy that tinting node, copy it up above there. And we're going to make sure that the default mask is sort of full. So the way we're going to do that is I'm going to say terrain for texturing. I'm going to say at mask equals 1, like so. Mask at. It needs to be a volume wrangle. At mask equals 1. The default tint is now going to be fully blue, like so. So if I set this to a nice dark green, and then we have a look at our second one, we can set this second layer to a sort of lighter green, maybe sort of verging on yellow, something like this. And we have our very first kind of background gradient, the base of everything to follow. All right, so next up, let's bring in a little bit of the slopes. So copy the object merge, wire up the slopes as the reference there. We're going to copy this piece of logic, these two nodes, and layer in the slopes this time. And we can see straight away we're getting something, sort of that lighter coloration on the slopes, but I'm going to go ahead and sort of tweak that a little bit further. Let's go with, yeah, a little bit more towards yellow, but a little bit more, somewhere between, a little bit more desaturated. Okay, like so. So we're getting that lighter color towards the top and this sort of like different kind of green on the slopes. And then what have we got next? The AO. So let's go ahead and grab the AO, wire that up, copy the logic once more, plug that in there. And then finally on this guy, let's try it. Go for something a bit darker, like so. Maybe slightly more verging on blue, just so we can see it for now. Now, I'm actually not completely happy with this because I think each layer that's coming in is overpowering the previous one. So what I'm going to do is I'm going to go back up to that AO, and you can see that we have that remap curve. And while I'm still previewing the final result, I'm just going to go ahead and tweak this profile. Okay, there we go. I'm just picking out the peaks. But actually what I want is I want to peek out the valleys a little bit more, or the occluded areas. I'm going to change the view distance slightly. Okay. Maybe make this even sharper, like so. Okay, that's definitely introducing too much. I think that I'm quite happy with that. And then actually, let's go back and preview the slopes, and let's do something similar there with the slopes and play around, see what kind of different effects we can achieve. Okay. Now I preferred the softer look, so I'm going to leave it like this, and I'm actually going to play again with this kind of gradient that we were playing with. I'm going to set it to smooth. I'm just going to drag these two kind of ends there around until I end up with something that I kind of like. All right, let's roll with that for the time being and check out the occlusion once more. And I think once again, I'm actually going to kind of reduce the amount of overall occlusion we're seeing there, just so we're picking out those kinds of lowland areas. All right, so we're starting to get towards something that's kind of cool. And let's just do that last kind of flow layer. Make sure we wire up the flow reference like so. And let's pick a color, any color. So something a bit lighter. I'm just going to play around until I find something I'm kind of happy with for this sort of little test terrain. I think that's feeling okay. Yeah, definitely towards the lighter end, I would say. And then let's go ahead and play around with that output once more. This time, because I want to do some more operations after the actual flow, I'm going to call this the flow field. I'm going to call this flow instead. And then on that object merge, we're going to wire up the null, wire that in there. And I'm going to go ahead and put down a HF mask blur. Yeah, soften that out a bit, maybe not too much, like so. And then finally, HF remap. It's going to allow us to remap the result of the mask that we have there, similarly to how we did it with the other fields. This gives us a nice degree of control. Let's go with smooth. Create these nice little kind of pockets, I suppose. Sort of pockets. For this one, I kind of feel like the default options we were getting were actually doing just fine. So I'm going to leave it as it was. Okay, so that's basically it. That's the terrain color authoring workflow. And in this case, I've basically just been mixing these sort of basic tint colors, as we can see here. It's one single color getting layered in this kind of stack of operations. When we see ourselves repeating these operations a lot, of course, what we tend to do is we tend to want to, if I just do this, tend to want to collapse that to a subnet and turn it into a digital asset, like so. So I won't be doing that right now because I think the sort of the principle of what we're doing here has already been explained as fine. And of course, if we wanted to, we could use that texture-based approach instead, which would fundamentally be a very, very similar. So let's just have a little look at how that might actually work right at the bottom. So we're going to wire our terrain in. And of course, by default, it just gets overwritten with the contents of the texture that we've loaded. So what we need to do instead is we need to control it with a sort of blend factor. So, or even a mask. So let's go ahead and kind of put down a volume wrangle like we did before, like so. And then we don't need anything to come in through the second input right now. Let's just say we want to get the color from the second input there. So we're going to go to our tinting. I'm going to copy the code inside of here. It's going to be quite similar. Oops. All right. So this time, source color is going to be unchanged. New color is not actually going to be, oopsie daisy. New color is not actually going to be this input vector here. It's going to be the volume sample from the first input. And we're going to get R. And we're going to reference at P. So this is actually getting the R channel. So we need to just declare that first ahead of time. And just like we did with the source color, we need to say new color equals new color 0 equals new color 1 and 2 equals, and then R, G, and B respectively. All right. So we can now see that. And we can see it's sort of getting applied, mixed in there. And why is it behaving so weirdly? Well, it's actually just because of the mask that we're using. So we're not supplying a mask yet. So that's the last thing we need to go ahead and do, is we need to go ahead and grab a Heightfield layer. We're going to take that in from the second input, as always. I'm going to get the mask from the second input. And this time, the mask is going to be some simple noise. So let's go and drag this up here, grab the terrain for splats. I'm going to create some relatively high frequency noise like so. And then we're just going to make sure that we actually rename it and then wire it in there. And now you can see that according to the noise, we're going to get a different result. Now, because this isn't a tiling texture, it of course looks a little bit weird, but the principle would be the same. And using this approach, you can sort of take your textures that you get from Megascans or wherever else and blend them together and create a really nice high fidelity end result, which you can export and use inside of an engine. So that's your texture-based blending. And just to push this that tiny bit further, go back and have a look at the original tint color. There it is, maybe after the after that light green. Okay, so we can of course modulate the height by some noise. So we can go create something going to be the height mask. Height mask. I'm going to rename this to height. We're going to instead, take that null. And the reason we use nulls is just so that we have an endpoint of some operations. And if we now get that height field mask noise, sorry, we're going to do add, yep. We can change the scale, like so. And we could do with a little bit of that probably on most of these. So call this slope mask. Call this slopes, probably would have been better if I'd used the null from the get-go. Do the same exact thing there. So you can start to see, what have I done? Tinting. And I see what's going on. The reason is it's now pushing the sign of final result beyond a value of 0 to 1, I think. Let me just verify that. So if you just do Heightfield remap, and we're going to remap the mask and just check what the range is by hitting compute range, we can now see it. In fact, it's pushing it beyond a value of 0 to 1. We can simply fix that. Instead of adding, we could just do a multiply operation there. We should do the same on the original thing over here. And there you can see how, as we start to introduce noise, we can start to break up and produce some more kind of granular and interesting and complex result. And of course, as I showed right at the start, we can take whatever output we produce. I'm going to call this RGB result, save to disk. And we have our output global color map ready to be loaded into an external program. And if this looks a little bit more saturated to you than it did in the Houdini viewport, completely agree. And we can just go ahead and make sure that we actually have basically applied a neutral white material to the terrain there. Because if we do not, then then basically the default sort of material color there is actually gray, right? So we're getting the result of the color we've applied and that gray. So we need to make sure that we just kind of blank it out to white, which you can do with the quick material node there, so that the end result is actually as bright as we would expect it to be. All right, so that's the RGB color workflow. If you fancy challenging yourself further, you can figure out how you would wrap all of these sort of functions up into actual digital assets, as well as thinking about how you might want to expand the color authoring workflow yourself and take it to sort of new heights. And I'd love to see how people get on with this, specifically as well for actually authoring materials, because although the Heightfield system was designed primarily with landscapes in mind, I think having access to the kind of color authoring workflow here as well really sort of opens up the doorways to using Heightfields for just general material creation and sort of substance designer alternative. It's my understanding that Houdini 20 has natively got support for vector volumes. So that means you no longer need to drive the color via 3 separate R, G, and B channels. You'll instead actually have the option to just drive the color with a single volume, which should simplify your life. Thanks again for watching, and catch you in the next one.